The Vane Air Flow Sensor measures the amount of air flowing into the engine with a spring-loaded air flap attached to a variable resistor or potentiometer. Vane Air Flow Sensors measure air volume and not mass. The incoming air strikes or pushes against the internal air flap on the Vane Air Flow Sensor, which also moves the variable resistor's sensing arm or wiper arm. As air flows into the engine, the mechanical air flap rotates further, causing the wiper arm to contact a series of resistors, changing the voltage signal output. The output signal on some systems is directly proportional, as in Medtronic systems, to the incoming air, while in other systems the signal is inversely proportional, as in Algetronic. In other words, if the Vane Air Flow Sensor electronic signal is directly proportional to the incoming air, then, as the airflow increases, the voltage output also increases, and if the system is inversely proportional, then, as the airflow increases, the output voltage signal decreases. Directly proportional Medtronic systems output a low voltage at idle with voltage increasing as airflow increases. Inversely proportional Algetronic systems output a high voltage at idle with the voltage decreasing as airflow increases. The ECM is programmed to the particular system and increases injector pulsation as more air enters the intake manifold. The Vane Air Flow Sensor has an air-fuel adjustment screw, which opens or closes a small air passage on the side of the Vane Air Flow Sensor. This screw controls the air-fuel mixture by letting a metered amount of airflow pass the air flap, thereby cleaning or richening the mixture. By turning the screw clockwise, the mixture is enriched, and counterclockwise, the mixture is leaned out. In addition to the regular airflow measuring function, some Vane Air Flow Sensors also employ an air temperature sensor and a fuel pump switch. The air temperature sensor is found inside the Vane Air Flow Sensor casing, and has the same electrical characteristics as a regular air temperature sensor. The Vane Air Flow Sensor flap also closes a set of contacts that activates the fuel pump relay coil or circuit opening relay. The contacts are actually closed as soon as the smallest amount of air pushes on the airflow flap. Once this happens, the fuel pump starts running and the engine starts. One of the main drawbacks of the Vane Air Flow Sensor is that it measures volume of air and not weight. As air temperature changes, so does its weight. There are more air molecules present when the air is colder than when it is hotter. As air temperature decreases, more air is absorbed by the engine, so there are drastic changes needed in the air-fuel mixture, depending on the temperature of the air. The air temperature sensor inside the Vane Air Flow Sensor somewhat compensates by signaling the ECM of any changes in air temperature. This is an older system, but is still often found in the field on older vehicles.